Hi, my dear student children. Welcome to the awareness session on the subject Mechatronics, newly added in the UPSC Engineering Services 2017 for Mechanical Engineering. I invite our Professor Satish Kumar to give a presentation on this particular topic, Mechatronics.
Hi students, myself I am Satish Kumar, Faculty of Instrumentation from ACE Academy. Here I am able to discuss about Mechatronics subject, which was included in IES 2017 for mechanical engineering people. This is the first time that subject was included in the syllabus of IES, just to give an awareness of electronics fundamentals to the mechanical engineering people. So coming to the syllabus, if you see the syllabus, the Mechatronics contains the combination of some basic sensors and actuators and their interfacing to digital devices like microprocessors, microcontrollers and programmable logical controllers. So if you see the syllabus, the topic wise, I am just reading the syllabus: microprocessors and microcontrollers and their architecture, programming and interfacing to I/O and computers, that is about MPMC part. Next coming programmable logical controller, in short it is called as PLCs. Next, sensors and actuators, and some sample of sensors he has given. One is piezoelectric accelerometer and Hall effect sensor, optical encoder, and finally resolver, inductocin, pneumatic and hydraulic actuators and stepper motor. That means in overview, in transducers, in electrical and communication part of IES, the subject was called as sensors and transducers. But here in mechatronics subject, they have given sensors and their interfacing to some digital devices. What is the essence of this subject mechatronics and why they have included for mechanical engineering people? The reason is, today the machines are compulsory has to be interfaced to the computers. So the students of mechanical should have some basic understanding of interfacing a lathe machine or a CNC machine or a mechanical device to an electronic component. So they should have awareness of these basics of electronics and controllers also. So the field of mechatronics is a combination of mechanical engineering and also some advanced softwares like CAD design and electronic concepts and some digital systems like microprocessors and microcontrollers. Today, this subject is having vast applications in the field of automation, aerospace, medical, defense and consumer products, and finally manufacturing. So let us see the overview of each and every topic. Let us introduction. The subject mechatronics is a combination of mechanical and electronics. As a technology advance is happening, the subfields of engineering are added together and the student should have awareness of that subject. So this subject includes mechanical, concepts of control and instrumentation and computer engineering. This is the first time a mechanical student is getting a computer based questions in the field of mechanics. So this is a completely new for a mechanical engineering, microprocessors, microcontrollers. Maybe in your academics you may not have awareness of this subject, but these subjects are very familiar to electronics background people. So in IES, as he has mentioned the names of microprocessors, microcontrollers, so just the basics of microprocessor, architecture of microprocessor, by taking one sample of one standard microprocessor like 8086 or one standard microcontroller 8051, we'll take that architecture and we'll study step by step. What is a microprocessor? Today everybody is aware of what is the technology of mobile is following. So the root of all these mobile technologies, first the processor. Microprocessor simply a CPU on a single chip but without memory, whereas microcontroller a CPU with a memory also on it. So comparatively microcontroller is somewhat advanced. So by generating a mechanical signal, the mechanical signal to be converted to electrical to digital, and the digital signal should be given to the processor technology. In our syllabus, we are going to discuss about architecture, programming and I/O. Maybe programming may be first time for the mechanical engineering students. Why? Because they may be familiar with the mathematical calculation of mechanics and controls. But here, first time they are going to get an introduction of assembly language programming, how to write a program. Just like in their academics they have studied C language, here they are going to study about assembly language programming related to processor. So if you see how to interface devices, as the mechanical engineering people are having many sensors and many actuators, we have to connect those devices to a digital system. So this is the way. The system contains a CPU and a memory and the external environment input output, and how they are interfaced to the memory and how the buses are interlinked. So that is given here. So we are going to take an architectural overview of processor to the external world. That external world involves your mechanical sensors. And this is the advanced topic. Just he has given a one phrase in the syllabus as PLC, Programmable Logic Controller, but it is a very important course nowadays for the electrical and mechanical engineers, those who are entering into the industries. Why? Because we have to program on the computer to control the entire industry. So this is one of the PLCs available in the market. If you see closely, that contains some input module and output module, and in the center there is a processor. So the mechanical engineer has to connect his particular sensor to this device, and by the computer he has to write a program, and the program has to be downloaded into this PLC, and finally he has to see the output. So this is for the first time. So what we are going to discuss is the architecture of the PLC, or the block diagram of the PLC. If you see the PLC block diagram, it contains an interface, input and output, and the center part is a processor. So in short, the input and output are the mechanical, and the center part is electronics. It is a combination of mechanical and electronics. So in IES level, what he is going to ask is just the basic architecture of the PLC. Why? Because PLC is a complete certified subject. It is a certification course available in the market. Here, in our teaching, in our classrooms, we are going to give the basic architecture and its programming concepts. See, this is the hardware of a PLC system. If you see the hardware of a PLC system, at the center there is a PLC blocks, at the left side there is a switch, at the right extreme there is a light. So this switch can be called as a mechanical sensor, the light can be called as an optical actuator, and the center part is a controller. So we are linking the mechanics to the electronics. The student should have awareness of different mechanical input devices, different mechanical output actuators, and they should have awareness of center part, that is PLC part. Now, this is very familiar for the mechanical, what is sensor and what is actuator. But here in the syllabus, this main intention is the sensor and actuator related to electronic side. So the sensor should generate an electrical output. Basically, sensor means a device which senses the change. But as we are living in the digital and electronic world, we want the output of the sensor as electrical. So a device which converts a non-electrical parameter into electrical. In electrical, it is called as transducer, but in mechanical, it is called as a sensor. The reverse operation of this, that means sensor converts non-electrical to electrical. The reverse, that means electrical to non-electrical, that is done by the actuator. So sometimes sensor is called as a transducer, sometimes actuator is called as a reverse transducer. So in the syllabus, he has given types of sensors. So before that, where is these sensors and actuators are essentially used? By this block diagram you can understand. This is a block diagram of a physical system which is followed in the industry. In the industry, we are taking one non-electrical parameter. See that bubble type of image, there is environmental parameters. Those environmental parameters are nothing but your mechanical parameters. The parameters can be a pressure signal, a flow signal, a noise signal, or a temperature signal, or a force signal, a speed signal, acceleration signal. So the physical atmosphere, from that we have to take input, that is done by sensor. So the sensor will convert the physical quantity into an electrical quantity. Why I am talking electrical? Why? Because we are interested in electronic output, electrical output. That's why it is mechatronics. So the electrical output is going to a intermediate stage where we are going to add some correction factor, and finally that is given to a controller. There the controller, many controllers are there in the market. In our syllabus, it is mentioned microprocessors, microcontrollers, and PLC. So we are going to discuss how a microprocessor is going to control, similarly how a microcontroller is going to control, similarly advanced PLC system is going to control. So the observer is going to see finally the quantity measurable. Sometimes this communication can be wired communication, or sometimes it can be wireless communication also. Wired communication means the sensor is in contact with the physical process and the user has to get a wired connection. Wireless means without wire, the observer can see over a distance of 100 meters or 1000 meters also. We have a list of sensors. If you see in the syllabus, he has very clearly mentioned some examples for the sensors. The first sensor he has mentioned in the syllabus is the piezoelectric accelerometer. If you see the image, the GIF image is very clear over there. It is going to convert a mechanical vibration signal into an indicator. So the vibrations is mechanical, that is converted to electrical voltage. The voltage is over a display. So mechanics, a mechanical sensor, and also an electrical display. So what is an accelerometer? Simply it is a vibration sensor. In your mechanical engineering, you may have studied how to convert a vibration signal to displacement. But here we are interested in not a mechanical output, we are interested in electrical output. How that mechanical vibration can be converted to electrical, that we are going to discuss in mechatronics subject. The other sensors he has given the syllabus, Hall sensors and optical encoders. This Hall sensor is a sensor for magnetic field. So whenever, what is Hall sensor? If you see this image, it is very clear. Whenever a conductor, an electrical conductor is kept in a 90 degrees magnetic field, if you observe that image, internal charge carriers are going to experience a force. So at the left and right, we are going to get some charge. That means if a magnetic field is present, we are going to get electrical output. A Hall sensor is a sensor for magnetic field. Next, coming to the optical encoder. First time we have included optical concepts also. Why optical concepts have included? As the latest engineering services trend is dependent on solar. Right now the power of the solar is running. So students should have awareness of how to convert solar energy. And what are the concepts related to optics? There are different sensors. He has given optical encoder. So this optical encoder is generally used to point out the angular position of a rotating shaft. In your mechanical engineering, you are very familiar about the position of a shaft as a shaft is rotating. Now the position of the shaft can be found out by using the optical encoder. The last, actuators. As I told, sensor part is converting non to electrical. Actuator part is converting electrical input to mechanical output. So there are different actuators. If you see the control signal, finally there is a energy conversion and output. In the syllabus there are different actuators, but in the syllabus he has given 3 actuators mainly. One is hydraulic actuator, other one is pneumatic actuator, and the next one is electric actuator. In the hydraulic actuator, I think mechanical people are very familiar with the subject of hydraulics and pneumatics. You have studied FM, fluid mechanics. In the hydraulics, we are going to use fluid properties, whereas in the pneumatic, we are using a gas properties. A liquid properties in the hydraulic and a gas properties in the pneumatic. By using these fluids, liquids and gases, finally we are going to control a movement that is done with hydraulic and pneumatic actuator. Coming to electrical, this is the first time that a mechanical student is getting electrical actuator. What is electric actuator? It is going to convert electric energy into mechanical energy. So we are going to give a mechanical output by giving electrical input. It is nowadays comparatively hydraulics and pneumatics, electric actuators are famous. Why? Because hydraulics and pneumatics, they are having the component as fluid. Fluid is having a frictional effect, cleanliness, but here in electric it does not involve oil, frictionless, electrical signal, so easily we can control. Under the electrical actuator, a stepper motor is given in the syllabus. So student is to get an awareness of what is stepper motor. You may have studied normal motors, but here you are going to study stepper motor. What is stepper motor? It converts electric pulses into discrete mechanical movements. That means the mechanical movement is going to be discrete, on and off type, a digital type. Overview of the syllabus. What is overview of the syllabus? What is a basic plan of the designer for the IES. He has given the basic sensors. Under the sensors, he has given some examples. Even though examples have been given, only piezo and Hall and optical is given. But we have to go through other sensors also, force sensors, flow sensors. That is not mentioned in the syllabus, but students should have awareness. Anyway, in the fluid mechanics, you may have studied flow sensors. And also actuators. Actuators, electric actuators is completely new. Under the electrical actuator, he has given stepper motor. And next, coming to microprocessor and microcontrollers, how these sensors have to be interfaced to the microprocessor, a microcontroller, and a PLC. Basically, the block diagram and interfacing. If you see the model questions in IES, the expected questions, if you see this, a piezoelectric sensor has a sensitivity of 2.5 millivolts per Newton. What is sensitivity? That students should have awareness of that first. Then if a static force of 5 newtons applied, then the output is dash. Generally, we know sensitivity means a change in output to change in input. So, as the units, if you observe the units of the question, piezoelectric sensor units, if you observe, it is given 2.5 millivolts per Newton. That means per 1 Newton force applied. Newton is a unit of force. 1 Newton force if you apply it, you are going to get 2.5 millivolts. So the input is a mechanical force, output is electrical signal. That is a basic thing of a sensor. But what he asked, if a static force of 5 newtons, so very simple, student will get an idea. For 1 Newton, 2.5 millivolts. Na? So for 5 newtons, how much I am going to get? 12.5 millivolts. So student will think that, but he should have awareness of working principle of piezoelectric. The working principle of piezoelectric is, piezoelectric sensor will work only for dynamic inputs, not for the static inputs. As in the question, a static is mentioned, so the answer is, the response is 0. So the correct answer is last option, that is 0 millivolts. Next, that means the student will get an idea, not only a mathematical concept, but also he should have some internal working procedure of piezoelectricity. What is static input? What is dynamic input? Which sensor will work for static only? Which sensor will work for dynamic only? And what are the static signals? What are the dynamic signals? The student should have a knowledge of this. Next, list of sensors. This is a very famous and very frequently asked question, not only in IES but also in GATE exam and non-GATE exams. Match the following. He will give a list of sensors, and at the right side he will give the parameter that sensor can measure. If you observe, cantilever beam, Hall sensor, piezoelectric sensor, venturi meter. The right side he has given the different parameters. As mechanical engineer very familiar, venturi meter is a sensor for flow. But the above cantilever beam is also, cantilever beam, I think you are aware of mechanical force. So they can sense the force and they can convert into displacement. These two are advanced, B and C, Hall sensor and piezoelectric. Hall is just now as explained, magnetic field, piezo as explained, acceleration. That means as a combination, not only mechanical, A and D are pure mechanical, student will have awareness, B and C are electronics. So he will combine the concept of mechanical and electronics. So the correct option, I think cantilever beam goes to 4, A for 4, Hall sensors will go for magnetic field, piezo will go for acceleration. The correct answer is option A. Okay, so coming to true and false. In IES we have assertion and reasoning questions, true and false questions. So students should have awareness. Which of the following statement is true? Piezoelectric crystal can be used for measurement of static pressure also. Inductive sensors have lot of frictional effect than mechanical sensors. Resolver sensors can be used measuring angular position or angular displacement. Mechanical sensors have infinite lifetime. So students should analyze each and every statement. First thing, if you compare option 2 and option 4, statement 2 and statement 4. Statement 4, mechanical sensors have infinite lifetime? No, they have some lot of weight. They will work according to the concepts of friction, so their lifetime is very, very less. Second, inductive sensors have lot of frictional effect than mechanical sensors, so almost 2 and 4 are close. Mechanical sensors having frictional effect, we have to apply mass, we have to apply force to move it. but whereas inductive sensors are working on the concept of electron. Electron friction, electron mass is less than the mechanical mass. That's the point you have to understand. The mass of a machine and the mass of electron, if you compare, the friction effect is very, very less in electrical sensors. So statement 2 is also wrong. Inductive sensor have less frictional effect and mechanical sensor have less lifetime. And as I told, piezoelectric crystal can be used for measurement of static. No, it can be used only for vibration dynamic. So options, definitely only third statement, as I told, optical encoders and resolvers, these two are used for determining the position of a shaft, moving shaft. So answer is option C. So these are the modal objective questions. In the modal objective questions, working principle of a sensor, true and false related to sensors, and different sensors and different parameters match the following. Now coming to the conventional, as you are aware, there is a good weightage for the conventional also in paper 2. What is a conventional? At the first time I am giving a model question on the conventional. First, the new topic that mechanical students may have heard, microprocessors, microcontrollers also sometimes, but PLC they have not heard up to now. Okay, this PLC is one complete subject for instrumentation people. So on this, how to program a PLC, what is a programming language that is used for the PLC, on that a question may be asked. So if you see, draw a RLL. What is RLL? Relay ladder logic. For PLC, if a switch is closed, to turn on a pilot light for one time. What does it mean? First, the programming language name is RLL. This is a RLL, relay ladder logic. So the PLC is a controller. The controller is going to control some external environment. To control that, the user has to write a program, but remember, the program is not text. It is not like a C language. It is not like a microprocessor language. It is a ladder language. Ladder means just like in our normal conventional ladder, how the rungs will be there, here also rungs. So what is the statement here? If you see, this input blue, a normally open contact, and the output a coil. So there is a symbol of input and there is a symbol of output. So when this is closed, the output is going to be on. That means if a switch, this symbolizes a switch, and the braces, open braces, that symbolizes a coil. So that means what is PLC, what are the components of the PLC, what are the programming concepts of the PLC, the student should have awareness. So here in our classroom teachings, we are going to give step-by-step approach of what is the input and output and what are the programming concepts. Okay. So even though the subject is new for the mechanical engineering people and the concepts of electronics are completely new for them, don't worry. In our academy, we are there to guide you, to give the complete concept, and not only technical wise, but also examination point of view we are going to give in a step-by-step approach. Okay?
Hi students, I hope you might have got some idea about the subject mechatronics. Thanks for watching, and if you like it, please recommend this to the friends whom you love. To win the race, join us.